Hey everyone, welcome back to Master J Skills. Today we are going to dive into the series of collection framework of a queue interface and its implementation. So let's get started with a queue interface. Queues are type of a structures that allows us to store and retrieve elements in a specific order. They are often used in a scenarios where elements need to be processed in a specific order like printing in a queue, call center, bank queues, etc. The queue interface is a part of a java.util package. The queue interface extends the collection interface, which means that it inherits several methods for adding, removing, and manipulating the elements. Queue is a data structure that stores elements in a specific order. Elements are added to the back of the queue and removed from the front of the queue, means first in, last out. Queue are often used in scenarios where elements need to be processed in a specific order, such as an printing in a queue. So now let's look into the what are the methods available in queue interface. Queue interface defines several methods for adding, removing elements from the queue. The most common methods include add, which adds the elements to the back of the queue, adds an elements to the back of the queue and returns true if the operation was successful. Remove, removes and return the element at the front of the queue. Poll removes and returns the elements at the front of the queue or returns null if the queue is empty. P returns the elements at the front of the queue without removing it, or returns null if the queue is empty. Apart from these methods, there are several methods which is supported by the queue interface, which you can go through in the queue interface docs. Now let's see what are the queue implementation. The queue has a below concrete implementation, that is linked list, priority queue, ArrayDeque. These are the pre-implementation of a queue interface. So let's look into each of them. Linked list implementation. Linked list is a doubly linked list implementation of a queue interface in Java. Each element in the list is stored as a node, which contains a reference to the next node in the list as well as the previous node. One downside of a linked list is that accessing the element in middle of the list can be slow, since it requires iterating through the nodes. This means that for application where elements access is important, like searching for a specific elements, linked list may be not the best choice. However, for applications where adding and removing elements in the primary is concerned, then linked list can be very efficient. So these are the points from the linked list implementation. Linked list implements both the list and queue interface in Java. Elements are stored in a node that contains a reference to the next node in the list, as it's a linked list implementation. So it has a nodes for a previous and next. Linked list provides efficient add and remove operation because elements can be added or removed from the beginning or end of the list in a constant time. However, accessing elements in the middle of the list can be slower because it requires iterating through the nodes. So this is about the linked list implementation. For better understanding, we will have a example in some other video. So now let's look into the priority queue implementation. Priority queue is an implementation of queue interface in Java that orders elements based on their natural ordering or a comparator. Elements are stored in a priority heap, which is a complete binary tree that satisfies the heap property. The heap property ensures that the elements at the top of the tree, the root node, is always the highest priority element. Priority queue provides an efficient add and remove operation. So it has some logarithm time because the heap structure ensures that elements are always in a correct order. However, accessing elements in the middle of the priority queue is not supported. So when an element is added to the priority queue, it's inserted at the next available leaf node in the tree and then bubbled up to its proper position based on its priority. This means that the element with the highest priority is always at the root node of the tree, which makes it easier to retrieve the next element in the queue with the poll method. Priority queue is a good choice for application where the order of an element in the queue is important and where efficient add and remove operations are necessary. However, accessing elements in the middle of the queue is not supported, so it may not be in the best choice of all the application. So this is about the priority queue. Now let's look into the ArrayDeque implementation. ArrayDeque is an implementation of a deque, that is double-ended queue, and queue interface in Java. Elements are stored in an array which allows for efficient access and manipulation of elements at both ends of the queue. Both the ends are available for manipulations, which is called a deque, double-ended queue. ArrayDeque provides a constant time operation, that is O of 1, for adding and removing elements from both the ends of a queue. However, accessing elements in the middle of the queue is not supported because it would require iterating through the array. So, which is basically the time consuming and not a performance wise choice while accessing elements in the middle of an ArrayDeque. So, ArrayDeque is another implementation of a queue interface in Java that uses a resizable array as its underlying data structure. Unlike LinkedList, which uses a doubly linked list, ArrayDeque stores its elements in a circular array, which makes it easy to add and remove the elements from both the ends of the queue. ArrayDeque is not the thread set, which means that it should not be used in multi-threaded application without proper synchronization. If thread set is required, then concurrent linked deque class can be used instead of a ArrayDeque. So this is all about the ArrayDeque. Like the Java queue interface and its implementations are a powerful tool for managing and processing elements in a specific order. With these tools, you can create efficient and effective solution for wide range of applications. That's all. Thank you for listening, and I hope you found this presentation as informative and helpful. If you want to learn more about the Java collection framework, be sure to check out my playlist of a Java collection tutorial by clicking in the link description below. Don't forget to subscribe to my channel for a more such great content. And if you found this video as helpful, please give me a thumbs up, and thanks again for watching. I'll see you in the next video.